here we go. Okay, so we are on 0 is the one we need to do. So we're gonna do all 6 trig functions. So let's go ahead and start with sine. So our sine at 0, so if I get out my left hand, 0, what finger should I put down? Pinky, yep, because this one's 0, so I put that down. So now sine, is that my fingers to the left of the one I put down or to the right? Right, because if you remember yesterday we said cosine is our x and sine is our y. So since sine is on the right side, I'm looking for my fingers to the right. How many fingers do I have to the right? 0. So it's always the square root of your fingers. So the square root of 0 over 2. Yeah, so that's just going to be 0. The square root of 0 is 0. And then 0 divided by 2 is 0. So our sine at 0 is 0. Which makes sense, guys, because if we think about our circle, so here's our unit circle. Here I am at 0 degrees. Well, if sine is my y coordinate, this point right here, is it moved up or down at all? So its y coordinate is at 0, isn't it? So its sine is 0. See how they're all connected? So the coordinates, the sine and cosine, they're the same. They're all connected, okay? So now, if we have sine, what is sine paired with? What should I do next?
Cosecant.
Cosecant. So let's do our cosecant. What do you guys think my cosecant at 0 is going to be?
0.
Okay, so let's think about this real quick. So if we had 0 divided by 2, if I were to flip this,
Well, you can't have 2 out of 0.
we'd have like 2
can't have 2
over
zeros.
0.
It's 2.
But you can't do that.
Can I divide by 0?
No.
No, so this one is going to be undefined. Okay? Or if you were thinking like this is 0 over 1, well, when I flip that, that'd be 1 over 0, which anything divided by 0 is undefined. So our cosecant at 0 is going to be undefined. All right, let's try cosine.
4.
So yeah, so Grant just said I have 4 fingers to the left of my pinky that I put down. So my square root of fingers, so square root of 4 over 2, what's that going to give me? 1, yeah, because square root of 4 is 2, so 2 over 2, which is 1. Which makes sense, because this is my x coordinate, my cosine is my x, and on the unit circle, this would be here at 1. Its x coordinate will be 1. Do you guys feel okay today? Does this, like, we're doing okay? Yeah. So then cosine, what did you guys just tell me it's paired with?
Oh, secant.
Secant, okay. So what do you guys think my secant is going to be at 0?
1 over 1, which is 1.
Yeah, 1 over 1, which is still 1. So my secant there is going to be 1. Because if I take this one and I flip it, still 1 over 1.
Okay.
So it's going to be 1.
Remember, you're always just flipping it.
Yep, I always just
I
flip
don't know what I'm flipping though.
it. You flip your answer.
Oh, okay.
So like 0 divided by
0
1.
is 0.
Yeah. Okay, what about tangent? How do I figure out what my tangent is? Sine over cosine. So my sine was 0. My cosine was 1. So what's that going to be?
0.
0. So 0 over 1, which would be 0. So then my cotangent at 0, how would I figure that one out? Yeah, it's going to be undefined because like 0 over 1, if I were to flip that, that would be 1 over 0, which is undefined.
This is making sense.
I told you, I said
So
just keep an
basically,
open
you have to
mind.
find sine and then cosine, and then you can find other ones.
Exactly, yep, so sine and cosine, so and you can find those from your fingers. Okay.
You guys wish you were smart as me.
Cool. All right, let's keep going. Okay, so then it says using the period to evaluate sine and cosine. So period is just a fancy name for going around our circle more than once. So if I have something like I'm trying to find my sine of 13 pi over 6, well 13 pi over 6 is nowhere on our circle, but I've gone around once. Because remember, the bottom number is always half of the circle. So from here to here, I went 6 pi over 6. Then from here I did 12. Then 13 would be like right here.
So then do we just find the next if we get 5 over 6?
Yeah, so then Grant just said that this angle is just gonna be pi over 6. Because 13 pi over 6 is the same angle as just pi over 6. So all I would have to do is figure out where that is first. And now, since it's sine, I can use my fingers. So pi over 6, what finger is that, guys?
That one,
Your ring finger.
The ring finger? Okay. So my sine of 13 pi over 6 is the same thing as my sine of pi over 6. Sine of pi over 6, is that my fingers on the left or the right? Right. So how many do I have? 1. So square root of 1 over 2, which is going to be 1/2. Yep, so for that one, it would just be 1/2, because remember, square root of fingers over 2. Which, if you look at your circle, that's what it says, like we filled that in yesterday. Okay, let's try cosine of -7 pi over 2. So first we need to figure out where this angle is. So if I draw myself a little picture, so what does the negative mean?
It's in a,
It goes.
in that column.
Yep, it's gonna go backwards.
Oh.
Then from here to here,
Oh, yes.
how many do I go?
Two.
2, yep, because whatever my denominator number is, that's like half a circle. So 2, 4, 6, and then 7 would be halfway, so right here, wouldn't it?
Yeah.
So this is gonna be my angle right here. Okay, because I went 2, 4, 6, 7, and then Marley, what did you say that angle is? Yeah, pi over 2, because from here to here is just pi over 2. So those are the same angle. So -7 pi over 2 and pi over 2 are the same angle. So now that we figured out where it is, what finger should I put down? The thumb, okay? So cosine, is that fingers to the left or the right?
Right.
left.
Left. How many do I have?
0.
0. So square root of 0 over 2, which is gonna give me what?
0.
0. Which, it makes sense because our cosine is our x, and right here, my x here is 0 because it's not moved in either direction. Do you guys see all the connections between everything?
I'm confused. I'm confused.
What are you confused on, Carter?
So. -7 pi over 2.
Yep.
I'm sorry.
How did I figure out where that was?
Yeah.
Okay, so the negative means I'm going in this direction.
Okay.
Okay, so I started at my x-axis because that's where I always start.
Yep.
So usually if it's positive, I go this way, but if it's negative, I go down first.
Okay.
So, and then whatever your denominator number is, because remember from, like, when you go across, like a full circle is 2 pi, so then just half of the circle, so from here to here is just pi. So if you were to simplify this, because we're in terms of 2, so 2 pi over 2 is the same thing as just pi, right?
Yes.
So whatever your denominator number is, that's how many you can count by, like for each half of your circle. So from here to here, I went 2 pi over 2, which is the same thing as pi, which I know from here to here is always pi.
Okay, so you go again.
So then I go again, and now I've gone 4. So I went 2, no, I went 4, then 6, and then if I went all the way, I'd be at 8, but I'm only at 7, so I only want to go halfway.
And that would be your pi over 2.
Yep, and that would be the pi over
How do
2.
you do that with bigger numbers where it's not like, it's either between this number or this number?
Like, it's not one of them that's like a finger, or,
Well, no, it's
Instead
like,
of
a-
like a 2, it's like 5 or something.
well, no, it's like,
Well, it's always gonna be.
it's like a bigger number, so it's like, maybe it's like, you have it as 30, like it's,
like something like 36 pi over 2, something like that, where I have to go around a lot.
well, just where it's like, you don't know where it would be in between those two because it's not, like you know how 7 is between 6 and 8?
Yep.
What if it was like between 36 and 18? But it's not like that specifically.
They'll all end up being, you'll be able to figure out.
It's either
what all
gonna
of
be
them
a
are.
6, 3, 4, or 2.
When you simplify.
Or a 0.
Yeah, or.
Yeah. So they'll all be like, you'll always be able to figure out where the angle is. So even if you're counting by something, like, say you're going by 12s, because that was one of them on the worksheet, we went like 12, 24, 36, and then it was like 47. Well, that would be 1 before the x-axis, so you can always figure out, then this would be like pi over 12, which we wouldn't have that because that's not on the unit circle.
So, yeah, go to Grant.
Grant.
Confusing.
So the negative symbol only matters the direction. you
Right.
change. Okay.
Yep, it won't affect like your answers being negative or anything like that. Okay? Alright, we'll move on, Jasmine, if you,
It's just, like, how do you know it's like right there and not like up a little more or down a little more?
It doesn't have to be exact.
yeah, it doesn't have to be exact. So the pictures just kind of help you figure out like what your reference angles are, or like roughly. So like every picture you're gonna draw, it's either gonna be like one of these, like on your quadrants, or it'll be like in the middles, or these angles. So it'll always be,
So, you're not gonna have one that's like here?
no.
Okay,
Was that your question?
yeah. like-
Yeah, no, you won't have anything, or if we do, we can do it in the calculator, okay? But yeah, so, also one thing I just kind of said to Jasmine, they'll all be numbers that are on the circle. If it's something like this, like I said that this was pi over 12, which is not on our circle, we would then do that in the calculator, okay? But you can't do all of them in the calculator, because those don't give you the, like, it'll give you the right answers, but it's gonna be decimals, but we want everything in fractions, okay? Like the square root of 3 over 2 is like the same thing as 0.707, so if you were typed in like sine of pi over 6 or whatever, and it was square root of 3 over 2, or whatever it is, it would give you that, but it needs to be the square root and like a fraction, not decimals, okay? So we shouldn't be using any decimals. Okay. So even and odd trig functions. So we've talked about even and odd before. And remember the way we solved those was we put negative x in for our x. And then if we simplified them out, and if it was completely opposite, it was odd. And if it was the same, it was even. Well, with these, until we understand more about their properties, you're just gonna have to trust me. So like if you were to put negative x in here, that negative would get factored out front and it would be opposite. But with these ones, they're gonna be even, they're gonna be exactly the same. And graphically, this will make sense, okay? But we'll learn a lot more about their properties. So for now, we just need to know this just a little bit, but we'll talk about this a lot more later, okay? And we'll solve some with stuff like that. No, just, you get your unit circle and your note card, but your first quiz, you don't, no. And your first test, or first quiz, you do not get your unit circle, because the first question is fill in the unit circle, so. So, that's when we keep going over the hand tricks and then stuff like that, okay?
Cause everything else is just like working with negative and positive.
So if you know your first quadrant, you can figure out everything else.
Oh, I left this in Mrs. Barnett's class where it was, in there.
So let's go ahead, let's
She
evaluate
put it on the-
some trig functions with a calculator. So if you don't have your calculator, grab your calculator.
Okay, I'm not passing.
Calculator, please, ready? One.
Okay.
What kids?
Equals up here.
Hi, that was my hero.
I know it's a credit. I
What
have
number are
mine.
you?
He's number 2.
Thank you.
Who's number 4? No way. Wait, it's you, because I think I'm 3. I'm 5.
Maybe Blake?
Oh, wait, that's right.
Oh, so we'll probably see him on what, test days?
Do you want us to write all that down?
I'm not getting
Yeah.
it. What is that here?
Is this for the example?
No. Okay, you guys, I thought I had a slide with this typed out, but I obviously didn't. So, yeah. Okay, so going back to the even and odd stuff, how I said even functions, so cosine and secant, if you were to plug a negative x in, it's gonna come out because even is the same, so it's gonna come out to your original equation. So if you're solving a problem and it says find your cosine of like a -4, you know that that would be the same thing as just cosine of 4, which is gonna help us with typing it into the calculator,
Are
okay?
those all even?
Cosine and secant are both even,
Oh, that's-
so they both come out, the negative, like the negative just disappears, okay? But sine, tangent, cosecant, and cotangent, the negative gets factored out front, okay? So I thought I obviously didn't have this slide, so if you jot that down, these are the properties that are gonna help you with solving, yes.
So the negative x in all of them is if there's a negative in the equation, like the x
Yeah,
is
like a
in the
negative angle.
equation.
Yes,
A negative at all?
no, a negative angle.
Oh.
Yeah.
And then the cosine x is the original equation?
Yep.
That's 5 controllers now.
So if you had something like cosine of -4, you know that that's the same thing as just cosine of 4.
Like 7 controllers.
Okay.
Or if you have something like sine of -6, that's the same thing as negative sine of 6. Okay, so those are equivalent. And this property just helps us with solving some of them, okay? You'll have a couple on your homework that you'll need to know that.
So first quiz is this, is study list?
No, the first quiz we can't.
But we still got a couple sections and we have like 9 sections in this chapter, so we'll do 1, 2, 3, and 4. Yeah, and we'll keep using it, so then hopefully in like a week or 2,
Is
when we
this
do
gonna
the
take
quiz.
us to Christmas?
Close. We'll get like, we either are gonna do a project for like a week or something, or like a week or 2 weeks, or like 2 different projects, I don't know, it depends on how in depth I make it, or we'll start a chapter, but we won't be able to finish it by Christmas break. So,
Or we can
Almost
watch
all the
Christmas
chapters.
movies.
I
on
know.
No
Mrs.
Christmas
Burns
break.
did that every single time, like in class, she would do that, and you come
Yeah.
back, you don't remember anything.
yeah,
It's kind of, yeah.
we'll figure it out as we get closer.
Isn't our Christmas break only like 13 days?
12.
Yeah.
Okay, so once you have those,
Two weeks is like
so
the
we're
max.
gonna evaluate with our calculator, because we're trying to find cosecant of pi over 8. Is pi over 8 anywhere on your unit circle or your fingers?
No.
No, so when we see something like that, we need to use our calculator. So the thing is, I need to make sure I'm in the correct mode. So your calculator has 2 different modes, radian and degree. And if you see something with a degree sign, you need to change your calculator to be in degree mode. If you see something with like pi or just a number, you should be in radian mode. So where that is next to second, you should see the mode button. And then if you go down, the 3rd one down, it says radian or degree. Make sure that radian is highlighted. So you can hit enter on radian, and then that'll put you in radian mode. And then you can quit out of that. So most of the time we will be in radians in this chapter. Later on in the year, we have to switch back and forth just depending on what we're doing. Okay, so it's always important because you'll get the wrong answer if you're in the wrong mode.
And radian's the pi fraction thing.
Yep, radians have pi or just the numbers. So only if you see a degree sign would you be in degrees. Okay, so if you see just a number or if you see pi, you're in radian.
Oh,
Okay.
so both of those are radian.
Yeah, both of these are gonna be radians. Do you guys see on your calculator anywhere to type in cosecant? I mean, I see a sine, cosine, and tangent button.
Where,
Would it be the -1 because it's the inverse? Cos -1?
Yeah,
Yeah.
it's,
No, don't use that one. That is gonna be the inverse.
Do second, and then do, sine, and then do sine.
So that'll give you, if you do second and sine, that's gonna give you the inverse of sine, which that is gonna give you, that's gonna give you like the angle measurement versus the answer. So we know that cosecant, guys, is the same thing as 1 over sine, right? So I can go ahead and type in 1 divided by sine of pi over 8.
How do you put pi in?
Pi is second and then that caret button, above the dividing.
oh, that's not it.
Divided by 8.
Yep.
2.61.
And Marley just said it's 2.61.
Do you have to put that in parentheses?
593.
sign?
You don't have to
I
put those
did,
parentheses.
but I don't know if it matters.
So you said radian?
Yep, you should be.
Five? Where the heck is five?
Second carrot. Sneaky little thing.
What?
Wait, what'd you get, Marley?
Never mind.
2.6.
Alright, is everybody being able to get the answer 2.61?
Yes.
We're all okay with that?
Why
Okay.
do you keep doing that?
So if you need to solve in your calculator for cosecant, secant, or cotangent, how you type it in is you take 1 divided by whatever function it's paired with, because we know that 1 over sine is the same thing as cosecant, or 1 over cosine is the same thing as secant, okay? So that's the way you would type those in. So let's try this cotangent of 1.5.
So you can have decimals for these, right?
Yep, we'll have decimals for these. So if you can't use your unit circle, if you have to use your calculator, just do decimals with like 2 decimal places, like to the 100th, so. Yeah.
So,
0.07.
What?
Is it 0.07?
For the next answer? You're ahead of me. How do I type this in, guys? So if I'm doing cotangent, what should I be typing in?
isn't it?
1 divided by tan, 1.5.
Yeah, 1 divided by tan of 1.5. And then, yeah, Shannon, it is.
7, 1.
Which is gonna give us 0.071. Everyone okay with the calculator?
What'd you guys get?
0.071? Yeah. Okay, we still okay? Okay, guys, last thing. So use the point to find the trig value. So I'm trying to find my secant at this point right here. So I don't necessarily know my angle. I don't know anything about my angle, actually. I don't know if it's one of them on the circle or not one of them on the circle, so I can't just think secant is 1 over cosine, like anything like that, okay? So, but I know, so if I draw this, I went backwards up here, here's my angle, and then I have this point at negative square root of 15, comma 7. Okay, so using this, I can go ahead and make myself a triangle. So I have a triangle. So if this is my x coordinate, the negative square root of 15, because that's my x coordinate of that point, that would be my distance down here. Is everyone okay with that? So negative square root of 15. Because that's gonna be, that's this length right here. And then what would this side be? Yeah, so then my height is 7. Okay, so if I'm trying to find secant, so of my theta, how,
Theta's what now?
I don't know my theta yet, so
But what is the, oh,
it's just like x, or it's just the angle, so like some mysterious angle down here that I don't know what it is. So, okay, so how do I solve for secant?
A squared plus B squared equals C squared.
Okay, so Madison said I need to use the Pythagorean theorem to find this other side, because if I think secant and cosine go together, don't they? So my cosine is my adjacent over my hypotenuse, and I know that secant, you always just flip your cosine. So my secant is gonna be equal to my hypotenuse over my adjacent. If I just flip what I know about cosine, because cosine was adjacent over hypotenuse, and I just flipped that answer to get secant. So now for my triangle, I just need to figure out what my hypotenuse is over my adjacent. Okay, so Madison said we're gonna use the Pythagorean theorem, so we have a squared plus b squared equals c squared. What's my a value gonna be, guys?
7 squared.
7 squared, yeah, we can do that one. What's my b value gonna be? Yeah, negative square root of 15 squared is equal to c squared. Okay, so let's solve this. 7 squared is,
49.
okay, negative square root of 15 squared is gonna be
Negative 15.
negative 15. And then is equal to c squared. 49 minus 15 is gonna give me what?
34.
Oh, so before we do, actually, instead of negative 15, so it's the whole quantity squared, so it's this whole number, the negative square root of 15.
Oh,
So it's gonna be positive, cause I'm squaring the whole number. So instead of 49 minus 15, what's 49 plus 15?
64.
Yeah, 64.
That's 8.
So Grant just said it's gonna be 8. So my C
That's what I calculated.
is gonna be 8. Okay, so I know that this side length right here is 8. So then with the triangle, I can go ahead, which one's my hypotenuse? 8. Which one's my adjacent?
7.
Negative square root of 15.
Negative square root of 15, because if this is my angle right here of my triangle, because here my angle came all the way around, so like this is the angle in here. And so your opposite is the one that's like opposite of it, like across from it. Your adjacent is your one that's close to it, so like it's on the same line as it, and then your hypotenuse is your diagonal one. Okay, so our adjacent in this case would be negative square root of 15. Okay, now if we think, so let's think about our quadrants real quick. So we talked about yesterday that all students take calculus, and that helps me know what should be positive and what should be negative in each quadrant. Well, here I am up in quadrant 2, okay, because I'm in this quadrant right here. So in this quadrant, only sine and which other one are positive?
Cosecant.
Yep, sine and cosecant, because they go together. So only sine and cosecant should be positive. So since I found secant, is it okay that it's negative? Yeah, it makes sense that it's negative. Yep, so our answer would be like negative and then the 8 over square root of 15.
Oh, so you don't want to.
Can I leave square roots in the bottom?
No.
Okay, so we got one last step. So what should I do?
Both sides of it.
Okay. So what am I gonna end up with?
8 square root of 15 over 15.
Yeah, 8 square root of 15 over 15, and that whole thing is negative.
What about the oh.
Yep, and the whole thing's negative. All right, how do you guys feel? Do we feel better
We were doing good until that part right
than that
there.
last one?
So you're
Okay.
done with
I actually
them?
understand it all.
Yeah, I'm doing good.
All right, guys, let me shut this off real quick.